Hey guys, I'm Manoj. Welcome to this episode from the course C# and .NET for Beginners. I create contents for developers. Subscribe to my channel and press the bell icon to get the latest updates from this channel. Let's see what is the agenda for this episode. In this episode, we will begin with a short recap of some important concepts that we have seen in previous season. Then we will have a quick overview of .NET type system. We will discuss why custom types are needed, and we will also list some commonly used custom types from .NET. Rest of the discussion will be focused on two important custom types, classes and structures. The episode will begin with theory part and it will also have some code along sessions. Make sure to stick around to the end of this video because there are some assignments mentioned at the end. You can try those assignments on your own, and if you need any help, you can always reach out to me via comments. So let's get started. If you were following the last season of this series, we mainly talked about built-in types. We had a look at very basic things like what are data types, how to declare variables, how to loop over collections, etc. We also have solved some basic coding exercises together in those episodes. If you have not watched those episodes, I would suggest to watch those episodes before proceeding further. Let's summarize what we have seen in previous season. We have seen what is SDK, what is runtime, and what is IDE. IDE is a place where developer can write the code, compilers can compile that code into assemblies. Assembly is any file with .dll or .exe extension, and runtime can take those assemblies and execute the code. A developer needs SDK installed on his development machine because SDK contains compilers, runtime, and some additional tools which can help developers. We also have seen how to create projects in Visual Studio. We tried to understand how code can be organized in projects and solutions. We have seen that a project directory contains code files directly under it, or it may contain multiple folders and those folders may contain the code files. Similarly, we have seen that a solution can contain multiple project files. We also have covered some basic concepts like namespaces and classes. We discussed about built-in data types and variables. As shown here, there are various built-in data types and we have seen how to use them and how to declare variables using those types. Here in this area, I have highlighted custom types because they were not covered in season 1. We are going to discuss about custom types in this episode and some of the coming episodes. In addition to this, we also have discussed about some important concepts like value types and reference types. We know that value types are treated differently than reference type. Value types are allocated on stack while reference types are stored on the heap. And we also have seen how to write conditional statements and iteration statements in the code. In addition to that, we also have seen what are arrays and what are collections and how to iterate over them. Okay, that was the short recap of previous season. I would again recommend to go through those videos if you have not seen them already. Let's move to the next section. Before discussing about the custom types, let's take a step back and let's discuss about what is Common Type System. Common Type System is also referred to as CTS. As we know, the .NET implementation is language agnostic. This means that .NET supports multiple languages. Whether you write code in C# or VB.NET or F#, .NET Runtime will be able to run that code. But .NET Runtime understands only intermediate language. So how is it possible for .NET Runtime to run the code which is written in various programming languages? The answer to this question is compilers compile the code that is written in respective programming language into intermediate language. For example, if we write the code in C#, C# compiler will take that C# code and it will compile that code into intermediate language code. Similarly, there are compilers for VB.NET and F# and all the other languages which are supported on .NET platform. And that's how multiple languages are supported by .NET. In order to support flawless, transparent, cross-language integration, .NET provides some rules and specifications. All the languages which wants to be supported by .NET, they must follow these rules and specifications. And Common Type System is a part of those specifications. Common Type System, also known as CTS, describes all the data types that are supported by .NET Runtime. CTS also describes the rules that all the languages must follow when it comes to working with those data types. CTS provides various primitive types as a part of system namespace, and CTS also provides rules about how the custom types can be defined and how they can be used. Let's take an example. Methods can be declared in the classes and methods in the classes can have implementation, while interfaces can also contain methods but they shouldn't have implementation. Similarly, when the methods are declared in the classes, they can have access modifier, but interfaces shouldn't have access modifier specified in the method signatures. And likewise, there are many such rules specified about various things that are supported by .NET. These rules serve as a guide while designing a new language for .NET platform. These rules ensure that the new language does not offer any features which are not supported by .NET runtime. Now let's try to understand the .NET type system. All the data types, whether it is a value type or it is a reference type, all of them are basically derived from a single type, system.object. And system.object is a reference type. Now we already know that runtime treats value types and reference types differently. So one obvious question here can be, how can value types and reference types both have a single parent? As the diagram shows, system.object is the parent of all the data types. So other reference types that we have seen in previous season like strings, arrays, they all derive from system.object as shown here. The data types that we are going to see in coming episodes like classes, interfaces, they are also derived from system.object. There is a special type, system.valueType, which is also derived from system.object. This class, system.valueType, is a very special type. It is because .NET Runtime treats all the types which are derived from this type as value types. So integer, long, boolean, char, everything is derived from system.valueType. Apart from those simple value types, there are two other kinds of value types, enumerations and structures. Enums and structs are also derived from system.valueType. Enums are derived from system.enum and system.enum is basically derived from system.valueType. And structures are derived from system.valueType directly. You may feel that the conversation went little off the track, but I thought it may be a good idea for us to have a look at .NET type system and to understand the type hierarchy in the .NET. Now that we know about the type hierarchy in the .NET, let's go back to our main topic of discussion, custom types. Now let's try to understand why do we need custom types. Let's say we want to write a program to accept name, email, and average grade of a single student. If we want to write this program for a single student, the program is easy. We need to take 3 variables and then we just need to read the inputs from the console and then process the data. Now let's try to make this program a bit complex. Let's say we want to capture this same information for 3 different students. How should we code this? One approach is to declare 3 variables for each student. So we can create 3 variables for names, 3 variables for holding email information, and 3 variables for holding average grades as shown in this snapshot. If this approach is used, the number of variables will grow linearly as the number of students grow, and it may also cause some repetition in the code. One important thing to note here is this approach works only if the number of students are known while writing the code. What if number of students are not known at the compile time? In that case, in order to accommodate variable number of students, one possible option is to create 3 lists or 3 arrays. First array for holding names, second array for holding email addresses, and third array for holding grades. We can assume that the values for student 1 will be available at index 0, values for student 2 will be available at index 1, and so on. We may use this approach and write code. The code will compile successfully and program will also execute. But wait, is this the right approach? Let's say we want to create an application for a university. The application should capture information about students, teachers, accountants, and all other employees. For every person, we need to capture some basic information like name, email address, phone number, etc. If we use basic built-in types in that software, you can imagine how many variables we would need. And you can also imagine how hard it would be to keep track of purpose of each variable. Also, as the code grows, it may become difficult to understand the code. So, what is the better way to solve this problem? Let's take a pause and let's try to understand what are some common basic goals while writing any code. First goal is we should always try to make the code readable and easy to understand. Second goal, we should group the related items together so that when the application grows over the time, it would be easier to understand which piece of code is contributing to which functionality. And third goal, is basically the dry principle. Do not repeat yourself. Try to avoid repetitions in the code. So what is the best way to achieve these goals? And the answer is using object-oriented programming. We should model the templates in our software in such a way that there should be one template for every real-world object that we want to model. All the information that we want to capture about those objects and all the operations that we want to perform on that information can be part of that particular template. And these templates can be created by using custom types. So we can capture all the student related information in a single template, or should I say a single type called as student. All the teacher related information can be captured in a single type, namely teachers, and so on. So the bottom line is we need the custom types to model the real world objects so that the software can be easy to read, easy to understand, easy to maintain, and easy to test. Now let's have a look at what are some commonly used custom types. .NET supports many different kinds of custom types. Some of them are listed here on this slide. Some common types are class, structures, records, interfaces, tuples, enums, and delegates. All the other types apart from structures and enums are marked in blue, while structures and enums are marked in light purple. It is because both enums and structures are value types. All the remaining types mentioned here are reference types. It means if we create a new enum or a new structure, their values would be stored on the stack. As I was saying earlier, all the other types mentioned here on this slide are reference types. So when we create a value of any of these types, they would be allocated on the heap. In this episode, we are going to discuss briefly about the basics of classes and structures. And remaining types we will try to cover in coming episodes. Before we move any further, let's have a look at some common building blocks that we need while declaring a new custom type. There are three different things that we need. Access modifier keyword is the first thing. There are various access modifier keywords. Some of them are public, private, protected, and internal. These keywords define who can access the custom types that we are declaring. We will have a separate session for understanding these keywords later in the course. The second thing that we need is custom type keyword. Depending on which type we want to declare, we need to select appropriate keyword. For defining new classes, we can use keyword class. For defining new structure, we can use keyword struct. For defining new records, we can use keyword record. For defining new enumerations, we can use keyword enum, and so on. The third thing that we need is custom type name. This is the name of the type that we are defining, and it is the name given by us. So, for example, we can declare a new class with name student for grouping student-related information and operations together. As I mentioned earlier, we will try to cover basics of classes and structures in this episode, and remaining custom types can be discussed in coming episodes. Now let's have a look at how to declare new classes. The syntax for declaring new class is simple. The access modifier keyword followed by the class keyword followed by the name of the class. For the sake of this episode, we are going to use public access modifier. And so, if we want to create a new type for capturing information of students, then we can create a new class by specifying public, class, and type name, which is student, followed by opening and closing curly braces. As you can see, currently this class is empty, meaning it does not contain any members. A class can contain many different types of members, and some of them are constants, fields, properties, constructors, methods, events, delegates, nested types, etc. In this chapter, we will have a look at only 4 types of members: constructors, fields, properties, and methods. Once you understand these 4 different types of members, you should be able to write new classes, or you should be able to understand the classes from already written code. Let's begin our discussion of class members with fields. A field is a variable of any type that is declared directly inside the class. For fields, parent context is class. If you remember, we wanted to capture 3 things for every student: name, email, and grade. We can add these 3 as fields in our class. So we can declare public string name as one field, public string email as another field, and then public double grade as the third field. The declaration of field is very similar to declaration of class. It also contains access modifier keyword, the type keyword, and the name that we have given to the field. Okay, now our class has 3 members. All of them are fields. How do we access these fields now? For that, we will have to create the instance of the class. We can create instance of a class as shown here. For creating the instance, we need to use new keyword. New keyword followed by type name followed by opening and closing parenthesis. This syntax will basically create an instance of student class. So we can declare a variable first student and we can assign the newly created instance to it. Okay, we have created the instance of the class. Now how to access the fields? When the field is public, it can be accessed from outside the class. So what we can do is we can use this variable first student and then followed by the dot, and Visual Studio will give us IntelliSense showing what is available for us to use. We can see all the 3 fields. So we can select the field, let's say name, and we can assign some name to it. And using the same syntax, we can also access the remaining 2 fields. This is one way of accessing the fields. We can create the instance using new keyword and assign it to a variable, and then on that variable, you can use dot to access the fields from the class. Alternatively, we can use object initializer syntax. The object initializer syntax is used to initialize certain fields or properties when we are creating the object. So while creating the object, when we use new keyword, after the type name and parenthesis, we can open and close curly braces, and within those curly braces, we can specify the field names and property names and assign some appropriate values to them. Okay, in both the examples, we have seen how to assign values to the class fields. For reading the values, the syntax is similar. We can add some console.writeLine statements to demonstrate how to read the values from the class fields. Okay, that was simple. Now let's move to the next type of member, which is properties. Let's now see what is a property. Generally, it is not a good practice to expose the fields to the external world. And that's why mostly in all the classes, you will see that the fields are private to the class. So private is another access modifier. When the field is public, it can be accessed from outside the class. But when it is private, the fields are not accessible from outside the class. They can be accessed only within that class. So again, why is it a good practice to declare the fields as private? The answer is for better abstraction. I will not go into details, but you can search more about this. This is one of the important concepts from object-oriented programming world. So the obvious question is, if fields are going to be private, how are we going to read and write values to fields? And for that purpose, we use properties. A property is a member that provides a flexible mechanism to read or write or compute the value of a private field. The syntax for accessing a value via property is exactly same as that of fields. So I can just say class instance.property name and I can either assign the value or read the value from that property. But remember, property is not holding any data. Every property will have a backing field and that backing field contains the data. Generally, every property has special methods called as accessors. Every property may have below mentioned accessors specified. So every property may have a get accessor to get the value of a field. It can have a set accessor for setting the value of the field. A property can either have set or init accessor, but not both. When set accessor is used, the property value can be set from anywhere. When init accessor is used, the value can be assigned to the property only when the object is being constructed. Both in set as well as init accessor, we can use value keyword which contains the incoming value. Now there can be different kinds of properties. A property is a read-write property if both get and set operators are specified. If only get accessor is specified, then the property is called as read-only property. Because get accessor helps you to only read the data and it doesn't have set or init, so you will not be able to set data to that property. If a property has get and init accessors, then the property is read-only and its value can be set only inside the object initializer. Sometimes property can have expression body definition syntax. Expression body definition syntax contains equal to sign followed by greater than sign. It's somewhat similar to arrow symbol, and it is followed by an expression to assign or retrieve the value from the property. For example, I can use expression body definition syntax here for the name property, and after the get keyword, I can use the arrow followed by the field name and semicolon. After the set keyword, I can use the same arrow symbol, but this time I want to set the value, and that's why the syntax is field name equal to the value keyword. The value keyword will contain the incoming value and it will get assigned to the field. I know this information can be overwhelming. Please bear with me. As I was saying earlier, every property has a backing field. A backing field can be explicit or it can be implicitly added by the compiler. For example, instead of having these private fields explicitly specified here, I can just remove them and I can just specify get and set accessors for these three properties. Compiler will automatically create the backing fields for these properties. Now let's move on. Let's talk about methods. A method is basically a code block that contains series of code statements. A method must have a name. It may or may not have input parameters, and it may or may not return the calculated value, but it always has a return type. If method does not return any value, then the return type of the method is void. So here, let's say I create a method display, which is not supposed to return any information. It is just supposed to display the information, name, email, and grade on the console. Because it is not returning anything, the return type of this method is void. And the name of method is display, and it does not need any input parameters. So just opening parenthesis and closing parenthesis, followed by opening and closing curly braces. And inside this method body, I can add the statements to display the information. We can declare methods inside class, record, or struct by specifying the access modifier, which is optional. The default is private if it is not specified. A return value, if it doesn't return anything, then there should be a void keyword followed by the method name, and after the method name there should be opening parenthesis and closing parenthesis. Now between this opening and closing parenthesis, we can specify the input parameters if required. Let's say we want to declare a new method which takes two integers as a parameter, it performs the addition and then returns the result. In that case, what we can do is we can use access modifier followed by the return value, which is int, followed by the method name, which should be, in this case, let's say add, and then inside the parenthesis we can specify two integers, int x, comma, int y. If there are multiple input arguments, they should be comma separated, and then in the method body we can use return keyword to return the addition. This line, which contains access modifier, the return type, the method name, and input arguments, this part of method is called as method signature, while this area within the curly braces is called as method body. While declaring methods in the class, this signature should be unique. There are many other concepts which are related to methods, but we are not covering them here. We will have a separate session for covering those advanced concepts about methods. Now let's have a look at what are constructors. A constructor is a special method in the class and it is executed whenever a new instance of a class is created. The name of this method is same as class name. It can optionally have an access modifier. So the method name can be preceded by public or private or any other access modifier. It can also accept the parameters. But this special method, the constructor, will not have any return type. For example, here in our student class, we can add a constructor which takes three parameters, name, email, and grade. And those incoming parameters we can assign to the properties. Because this constructor is marked as public, it can be accessed from outside the class. So we can create the instance of class using new keyword and we can specify the input values within the parenthesis. On that instance, we can directly read the properties because constructor has initialized the fields which are backed by those properties. And we can see that if I run this program now, I should be able to see the details, name, email, and grade of the students. There are some other interesting things that I want to mention here. Class is a reference type. The variable which points to the instance of the class contains the address where the object is created. So if we compare two instances, they will not compare the values. They will basically compare the addresses where the values are located. So let's say I create two instances of student type using new operators as shown here. And then I try to compare these two values. This expression will always be false as the two objects are created at two different memory locations. On the other hand, if I just create a single instance of the student type using new operator and then assign this same instance to two different variables, then both the variables are pointing to the same object. And then if I try to compare these two variables, this comparison will always return true. Another interesting thing, there can be nested classes. So one class can be defined within another class. So if I want, I can declare another class inside this student class like this. One final thing, we can create arrays and collections of classes. Here with new keyword, I was able to create single instance of the student class. But let's say if I want 10 instances, I can declare a list of students and then I can run a loop to populate that list. Also, let's now take another example. Let's say this is our student class and then we want to create another class which is supposed to hold course related information. Let's say course ID, course name and course description. Okay, now our course class is ready. Now let's say every student can take multiple courses. So one student can be associated with multiple courses. Now in order to model this relationship, we will have to declare a collection inside the student class. So inside the student class, we can just create another public property and the type of that property would be list of course and the name would be opted courses or maybe just courses. Now let's modify the constructor to take list of courses as input parameter. Okay, we are done. Now whenever we use this constructor to create instance of student type, we can pass name, email, grade as well as list of courses which this particular student is attending. So we can modify the code in the main method. We will create instances of student class. We will create some instances of courses class and then we will randomly assign some students to some courses and that's it. We have successfully modeled this relationship. Okay, we have successfully modeled this relationship. Now let's add another class, Students Manager, which will contain methods to manage multiple students. We are not going to save this student information in a file or in a database. What we will do is we will just declare an in-memory collection of students inside Students Manager. So I will add a property list of students get set and then we can add methods in the Students Manager to add, update or delete the records from this list. Add method will basically take a student as an input parameter and this student will be added to the list. The update method will receive the student object. Using that object, we can find if the student with provided ID exists in this list or not. If it exists, then we will update the associated information in that particular object. And we can add another method delete which will take student ID as input parameter. It will not return anything, so the return type is void and it will search the record with the given ID and if it is found, it will remove that record from the collection. Now if you remember our original problem statements, we wanted to store some information about the students and this is one of the solution to that problem statement. We have modeled relationship between student and courses and we have a Students Manager class now which can add or remove the students from the in-memory collection. Now one obvious question is it the perfect solution? Well, I think no solution is perfect and every solution has its own trade-offs. In my opinion, if you are a beginner, this solution is just fine for now. But just for your information, one issue with this solution is Students Manager class works on in-memory collection. In real-world applications, such data is generally stored in some kind of data store. But now as you can see, we have grouped the related information together in 3 different classes. And if we want to store this list of student into database or any other data store, we know where we want to make the changes. Okay, this concludes our discussion about basics of classes. Now let's move on. Now let's have a look at what are structures. A structure is basically a value type that can encapsulate data and related functionality. As far as declaration is concerned, the declaration is very similar to class. We can just use access modifier public followed by the keyword which is struct followed by the structure name. In this case, let's say student. And like class, there can be different kinds of members inside the structure. But one important distinction is structure is a value type. So when we create an instance of a structure type, it will reside on a stack. There are some other differences too. For example, within the constructor, we are always required to specify the values for all the fields before leaving the constructor. Now one obvious question here is, if classes and structures both can contain similar type of members, when to use structs or when to prefer classes over structs? Well, as a rule of thumb, in majority of cases, classes should be preferred over structs. We should consider defining a structure instead of a class if the instances of the type are commonly short-lived, they are small, and they are commonly embedded inside other objects of the class. Again, I will not take a deep dive into this topic, but if you are curious, you can go to documentation and read more about it. If you find out some other considerations which guide when structs should be preferred, let me know via comments. Okay, that was the short introduction to structures. Because the syntax is very similar, I have not planned any code along session for this topic. Now let's move on to the last section. Let's move on to the final section of this episode, the exercises section. As the name suggests, this section shows some exercises, some assignments that you can try on your own. The first exercise is you can create the class math operations, which contains 4 different methods. Add for adding 2 numbers, subtract for subtracting 1 number from the other, multiply for multiplying 2 numbers, and divide for dividing 2 numbers. So each method should take 2 parameters as input, and these 4 methods should return the outcome of the arithmetic operation. The second exercise is a bit interesting. You can create a to-do item class which contains ID, which is integer, description, which is description of the task, scheduled on, which is date time, which indicates the date and time on which this task should be done, and the status of the task, which should be either to do, in progress, or completed. After creating this to-do item class, create another class, to-do list manager. This class should contain the list of to-do items, and then it should contain different methods to manage that list of to-do items. It should contain an add method to add a new to-do item to the list. It should also contain methods to display all the items. Edit method should be able to update the existing record from the list, and delete method should be able to remove the record from the list. This exercise is very similar to the code along session that we did for classes. The third exercise is create a course class which contains course details like ID, title, description, fees. Then create a student class which contains student details like ID, name, email, and a student can take multiple courses. In addition to this, create another class, students manager. It should contain methods to add, update, and delete the students from the list. Now this part is very similar to the activity that we have done in the code along session. In addition to these methods, add 2 extra methods, register and deregister. These methods should take the student ID as a parameter and the course that needs to be registered or deregistered for that particular student. If register method is called, then the input parameter student ID should be used to identify the student, and for that particular student, a new course should be added in list of courses. And when a deregister method is called, we should try to find the student with given ID. If the student is found, then try to find the course with the given ID. If the course is also found, then remove the course from the list of courses for that particular student. I hope these assignments are clear, and if you have any questions, any queries, you can always reach out to me via comment. So let's summarize what we have discussed in this chapter. We have discussed what is common type system. We have seen the hierarchy of types in .NET. We have seen that system.object is parent of all the types in .NET. Then we have discussed why custom types are needed. We also have listed down some commonly used custom types from .NET. In this chapter, we also have seen how to define classes which can contain fields, properties, methods, and constructors. We also briefly touched upon how to define structures. You should be able to define new classes and structures by yourself now. You should also be able to read the code which contains these custom types. Alright guys, that's it for this episode. If you found this content helpful, then like this video, share this video, and subscribe to this channel. If you have any feedback or suggestions, please let me know via comments. Alright guys, see you in the next episode. Namaste.